Hello and welcome to the notes on factoring trinomials. This is 2.5 and 2.6 all rolled into one. So as we get started here, we are going to use some of the tools that we were practicing previously, one of which was factoring out the GCF, which was the lesson prior to this, which in 2.4, and then also practicing with finding integers that give us a product and specific sum. So the list of purple here is going to be the steps that I'm going to take as I work through these problems. So when factoring trinomials of the form ax squared plus bx plus c, the very first thing I always need to do is to check for the GCF. So my greatest common factor is the first thing I'm going to look for. I'm going to go ahead and I'm going to get into this problem number 1 right here. And I'm going to go through and I'm going to look for what common factor can I take out of every one of those terms. So I've got an x squared and a 3x and a minus 10. So I check the numbers first. I have a 1 and a 3 and a minus 10. There's actually no number that goes into 1, 3, and 10 other than 1. And then I can look at the variables x squared, x, and no variable. There's also not a variable I can take out. So for this problem, there is no GCF. I'm going to break it down, and in 2.4, we were writing lists of prime factorization. So I'm going to do that on the side here, just to kind of relate it back to what we've done. So if I were to write out all the prime factors of x squared, I would have x times x. All the prime factors of 3 times x, 3 is prime, so this would just be 3 times x. And the prime factors of 10, when I do my factor tree, the things that multiply to 10 are 2 and 5, so I would have negative 1 times 2 times 5. If I look at those lists, you'll notice that there's nothing that all of them have in common, which is why I have no GCF here. Okay, that's my first step. The second step is to find two numbers with the product of AC and the sum of B. So when I compare my standard form to my equation I have here, I want to multiply A times C. So I'm looking for the product of A and C. A is the coefficient of x squared. C is the constant. There's no number in front of x squared, which means it's automatically a 1. 1 times negative 10 gives me negative 10. And then the 3 is going to be my sum. So I am looking for numbers that have a product of negative 10 and a sum of 3. If I can't come up with this in my head absolutely, then my strategy is to make a list of all of the factors of 10. So 1 times 10 gives me 10. 2 times 5 gives me 10. And when I keep going up, 3 doesn't go into 10, 4 doesn't go into 10, so I stop. Now I look down those pairs and I look for two numbers that add or subtract to 3. 1 plus 10 is 11. When I subtract, I get 9. That doesn't give me 3. 2 plus 5 is 7. When I subtract, I get 3, so I may have some combination there. So I have a 2, and I have a 5. I need a negative product, negative 10. So one of these needs to be negative with a sum of 3. So you might have to write and erase and kind of do a little bit of figuring here. But this works when the 2 is negative and the 5 is positive. Okay, that's my second step. Third step is to rewrite the linear term, or the middle term. So my original problem is x squared plus 3x minus 10. The reason I do this whole product sum exercise is to figure out the coefficients to rewrite this middle term. This middle term right now is 3x. I'm going to rewrite it with the coefficients that we found here. So I'm going to use minus 2x plus 5x. Okay. I know that minus 2x plus 5x gives me 3x. All right. This is how I split it up. I need to split it up because I need 4 terms in order to use this method of factoring. So that's my third step. Now, I am going to utilize this box to teach factoring, and while we get really good at factoring, and later off in the school year, I will try to pull that tool away so that we can do it without it. But for now, it's a great organizational strategy to help us really be clear about what we're doing here. In this box, I'm going to write some instructions up here next to my steps too. In this box, the top left-hand box is always going to be ax squared. It's going to be your term with the highest degree. And the bottom right-hand box is going to be your constant. So for us in this situation, I have x squared in my first box, and my bottom last box is going to be my constant. I wouldn't be able to fit my original problem with the 3x into this square. Now I have a minus 2x and a plus 5x, so I'm going to fill those in. It doesn't matter which one you put in which spot. If I do it one way and somebody does it and somebody switches the negative 2x and the 5x, that's fine. You'll still get the same answer. Okay. My next step is to factor out the GCF out of every set of numbers. So my strategy here is I'm going to look at the first row, I'm going to take out the GCF. I'm going to look at the second row, take out a GCF. I'm going to look at the first column, take out the GCF, and the last column, take out the GCF. So here we go. X squared plus 5x. What can I take out of these two terms for my first row? Well, they have an x in common, so I'm going to pull that out. What can I take out of the second row? Negative 2x minus 10. We can take out a 2. We also have to take out a negative. So if you remember back to our last lesson, the instructions were if the leading term is negative, you always have to take out a negative, and this is no different. So my leading term, if I were to look at this expression, negative 2x minus 10, my leading term is negative, so I have to take that negative out. Now I'm going to look at the first column. X squared minus 2x. What can I take out of both terms? Well, they both have an x in common, so I'm going to take that out. All right. Look at the next column. 5x minus 10. I can take a 5 out of both of those, and I'm going to put a plus 5 since I can take out a positive number. What I've created here is I have two expressions kind of embedded in here. So I've got the x plus 5, which is one of my factors, and I've got the x minus 2, which is a factor. This product is an equivalent statement to my initial problem. So this is rewritten in factored form. If I were to take that and I were to multiply it all out, I would get the answer that I started with. So if I did x plus 5 times x minus 2, this is a good way to check your work if you wanted to. You would see that I can work backwards and get what I started with, okay? This isn't actually part of the working towards the solution, but this is how I could check my work if I were working backwards. Okay, first one done. All right. You may want to jot down this list of steps here or take a picture of it or something, because as I move my screen up, it's going to be out of view. So problem B. Step 1 is to take out the GCF. So 5x squared minus 35x plus 50. So GCF, I ask myself, what can I take out of all three terms? With a 5 and a negative 35 and a 50, I know that I can take a 5 out of all of those. When I look at the variables, I have x squared, x, and then nothing. If this is beyond your scope right now, then you are free and welcome to continue to write out the factors. Okay. So I'll show you that in a moment. When I take out the GCF, when I have a factor, I take it out and I put it in front, and what I'm essentially doing is I'm undistributing it. I'm dividing by it. So what do I have left? 5x squared divided by 5 leaves me with 1x squared. Minus 35x divided by 5 leaves me with minus 7x. Plus 50 divided by 5 leaves me with plus 10. Similarly, if I were to take the time to write out all the factors for 5x squared, I know you could do some factor trees and get these lists, but I'm going to kind of skip ahead a little bit here and just jot them down. 5x squared breaks down into 5 times x. Negative 35x breaks down to 1 times 5 times 7 times x. And 50 breaks down to 2 times 5 times 5. Looking at this list, what do they all have in common? They all have a 5, which is why I pull out the GCF. And then everything that's left are my terms inside. So x times x gives me the x squared. Negative 1 times 7x gives me the negative 7x. And the 2 times 5 gives me the 10. It's the same work. I'm just trying to skip us ahead a little bit and doing these smaller ones without having to write out all the prime factors. Okay. Step 2. I am going to use the product sum to find two new numbers to how to split up my middle term. I have 1 times 10, and then I've got a negative 7. So I am looking for two numbers with a product of 10 and a sum of negative 7. The factors for 10, I already actually did them above, so they're the same. This time, I'm looking for a product of negative 7 instead of for 3. Still have to use 2 and 5. I just need different signs. So I have 2, I have 5. For them to multiply to 10, they need to be the same signs. And to get a sum of negative 7, I'm going to have a negative 2 and a negative 5. That tells me how to split up my middle term. So x squared minus, I'm going to pause there for a moment. I have this 5 in front here. I am going to really put it aside and then just make sure I include it in the end. You could highlight it if you want it to stick out so that you don't forget it, because it's easier to forget at the end. But when I continue to factor, I'm really just factoring this trinomial inside. So I have x squared minus 7x plus 10, and when I rewrite that, instead of minus 7x, I'm now going to use the minus 2 and the minus 5. So I have minus 2x minus 5x. And that's what goes inside my box. All right, my first box is going to be the x squared. My last is going to be the 10. And then, reminder, it doesn't matter which order you put these in. And now I begin to factor. So I look at each row and each column differently. The first row, what can I take out of x squared minus 2x? They have an x in common. Second row, what can I take out of negative 5x and 10? 5 and 10 are both divisible by a 5. Because my leading term is negative, I have to take out the 1. Look at your first column. X squared minus 5x. What can I take out of both? I can take out an x. Next column, minus 2x and 10. I can take out a minus 2. So my final answer here, I'm going to have the x minus 2, and I'm going to have the x minus 5. And what's that thing I warned you not to forget? Is the 5. If we leave that off, it is not all the way correct. Okay, so there is my factored form. Okay. Problem C. Look for the GCF. So with 3 and 14 and 5, what number can I take out of all three of those? No number. And then I check the variables, x cubed, x squared, and x. Ooh, this time I can take out an x. All right, great. So I rewrite it. X times, and then everything that's left. So I have 3x to the third. And when I divide by an x, that subtracts 1 from the exponent. So I'm left with 3x squared. Minus 14x squared, I divide by one of the x's. So that leaves me with minus 14x. And then with minus 5x, I divide by x, and I'm left with minus 5. Step 2, do the product sum. For the product sum, I am going to be careful to multiply my a value times my c value. So 3 times negative 5 gives me negative 15, and my sum is negative 14. So I want a product of negative 15 and a sum of negative 14. So I make a list of what things multiply to 15. As you get good at this, you'll have to make more and more lists, and you may have, fewer details written down because you can do more of it in your head. What is going to add or subtract to 14? And I'm going to need to use 1 and 15. So how can I work that out? Let's see. When I have the 1 and the 15, in order for the 14 to be negative, I'm going to have a negative 15. And then check, 1 times negative 15, does that give me negative 15, my desired product? Yes, indeed. Okay, so I have plus, this is just the coefficient, plus 1x minus 15x. Okay, so 3x squared is going to go into my first box, a negative 5 into my last box, and then you can put these kind of in whatever order works for you. So I'll put the plus x here and the minus 15x here. If you swap those boxes, that's perfectly fine. Now I take out the GCF out of each pair. So looking at my first row, 3x squared plus 3. What can I divide out of both of those? They each have an x in common. negative 15x minus 5. Well, I could take a 5 out of both of those, and since the first term is negative, I must also take out a negative. Okay. 3x squared minus 15x, my first column. What can I take out here? Well, I can take a 3 out of 3 and 15, and they also have an x in common. In the next column, out of x and minus 5, there's nothing that those have in common besides a 1. If there's nothing else you can take out, you have to just put a plus 1 here. Okay, absolutely required. Okay, let's see what we got now. So I have one binomial, which is 3x plus 1. I have another binomial, which is x minus 5, and then go back and check. Did I have any GCFs? Yes, I had an x. Boom. There we go. If you feel confident at this point, I would suggest pausing and trying to do the next problem on your own. There's a lot of examples here, so some of them I'm going to continue to work through on the video, and then some of them will just be completed at the end to kind of show you some other solutions. Hopefully you took a moment to work out problem D. We'll do it together now. So first thing first, I factor out the GCF. In this case, I can take a 2 out of everything. When I bring a 2 in front, I'm left with 2x squared plus x minus 6. The next step is to look for the GCF. Is to look for the product sum. So I need two numbers that have a product of negative 12 and a sum of, there's not a number in front of this x, so I just need a sum of 1. So all of the things that multiply to 12, 1 times 12, 2 times 6, 3 times 4. If I want a sum or a difference of 1, then I need the 3 and the 4. So I'm going to rewrite this for, 2x squared. And instead of the plus x, let's see, I have a 3 and a 4. And to get a positive x, the 3 will have to be negative. So I'll have a minus 3x and a plus 4x and a minus 6 at the end. So I put that in my box. 2x squared minus 3x plus 4x minus 6. And I look for my greatest common factors for each column in each row. For 2x squared minus 3x, I can take out an x. For 4x minus 6, I can take out a 2. 2x squared plus 4x, I can take out a 2 and an x. Minus 3x minus 6, I can take out a minus 3. It has to be subtraction because this first term is subtraction. So let's see, I've got a 2x minus 3 as one of my binomials. I have an x plus 2 as another binomial. And then I'm going to put the GCF in front of all of that. There is my equivalent expression in factored form. Okay. Problem E, and then I'm going to give you a couple to do on your own. Step 1, take out the GCF. Here, my GCF is not necessarily numerical. So let's see, I've got x to the 4th, x to the 3rd, and x squared. If it's helpful, you can take this and you can write it all out. You can write out a product of the prime factors. I notice that I can take an x squared out of everything. So that leaves me with an x squared plus an 8x plus a 16. To split up my linear term, I am looking for two numbers that have a product of 16 and a sum of 8. One and 16 gives me either 17 or 15. 2 and 8 either gives me 10 and 6. 4 and 4 gives me 8 or 0. So I will get 8 by having a positive 4 and a positive 4. I'm going to rewrite my middle term. So when I'm continuing on factoring, remember I'm just dealing with the trinomial. So x squared, instead of plus 8x, I now have plus 4x plus 4x. If you want to try and do this the rest of this problem from here, that would be a great start. X squared plus 4x, I can take out an x. 4x plus 16, I can take out a 4. X squared plus 4x, I can take out an x. 4x plus 16, I can take out a 4. Sounds a little redundant. So I do have x plus 4 times x plus 4 all times my GCF. This could be written as x squared times x plus 4 times x plus 4. It could also be written as x plus 4 squared times x squared. Because the x plus 4 occurs twice, I could just rewrite it as squared. Okay. So please pause, and on part 2, I would like you to do F and G. This video is going to skip ahead with the answers. So go ahead and pause it here, and then you can check your work on F and G after you give them a try. Okay, to highlight the answers here, you've got the complete solutions worked out, so you can pause this and check all of your work. Keep in mind that when I am looking at the answers to these, I wrote the answer to F as parentheses 5x plus 2 plus or times parentheses 2x minus 1. If you flop those parentheses and write them in a different order, this has the same meaning. So it's okay if you have 2x minus 1 times 5x plus 2. Those are the same things because multiplication is commutative. Then for G, don't forget to have your 2 for your GCF in front times 4x minus 5 times x plus 1. All right, 2 more to go and we'll wrap it up. 12x cubed minus 3x. If you want to give this a try on your own, you're welcome to. This one's a little bit of a special case. So the GCF, let's see, what can I take out of 12 and 3? A 3, and x cubed and x, I could take out an x. What that leaves me with is 4x squared minus 1. And you may be asking yourself, there's only 2 terms inside the parentheses. What do I do? Sometimes it happens that we kind of lose that middle term, and that's okay. It's going to be kind of one of these special cases. So what we're going to do to kind of rectify that is I'm missing my linear term. I'm missing my b term, my bx. I'm going to write it in with a coefficient of 0. It's the same thing. 0 times x is just 0. It's like it's not even there, but I'm writing in kind of like a placeholder. Because I still need to do my product sum, where I have two numbers that multiply to negative 4 and add to 0. In order to get a sum of 0, if I'm adding two integers, they must be opposites. So I get 2 and -2. So I'm going to rewrite this. I'm just looking at what's inside the parentheses, remember? So I have 4x squared. I'm going to have a plus 2x, a minus 2x, and a minus 1. So this idea that I'm missing my middle term here, that's what makes this a little bit unique. Most of the process is the same, but you can definitely easily get thrown by missing a term. 4x squared plus 2x minus 2x minus 1. It's also very specific that it's the middle term, the linear term, that's missing. If a different term is missing, then that means that this is no longer a quadratic trinomial, and we don't factor it the same way. Okay, so I go ahead and I take out my GCF. If the video is going a little fast for you, slow it down or pause it. It's important down here when I am factoring the minus 2x minus 1, there's not a different number that I can take out of 2 and 1 except 1. But remember, I've got to take out that negative because my leading term is negative. So for my factors, I get a 2x plus 1 and a 2x minus 1. And my GCF was 3x. When I look at these, something a little special happens here. Those two binomials, 2x plus 1 and 2x minus 1. When all I do is change the sign in the middle, those are called conjugates. And we'll get into that more later. But what happens when I have conjugates is something always cancels, which is why you lost that middle term in the original equation. And then this last example, I've thrown in another variable in there. So this can throw some people, but the process is the exact same. You just have to watch more variables. First thing first, always, always, always check for the GCF. Is there a number that I can take out of all three terms? Yes. Is there a variable I can take out of all three terms? No. The first term has x's, the middle term has x's and y's, and the last term has y's. They don't have anything. They don't all have the same term. So I factor out a 4. That leaves me with 2x squared plus xy minus y squared. So remember, I'm only multiplying my coefficients. 2 times -1 gives me a -2. And then a +1. So what multiplies to 2 and adds to -1? I don't have a lot of choices here, so I've got 1 and I've got 2. I need a +1, so the 1's going to be negative there. All right. Remember, I'm just rewriting what's inside my parentheses. So I have 2x squared. When I rewrite my middle term, I've got a -1xy and a +2xy. Remember, my goal is that I am splitting up this term, right? I'm figuring out what coefficients can I use to rewrite that term. So I get this. We write it in our box. We factor the same way. You just got to look out for more variables. Look at the first row, 2x squared minus xy. Ooh, they both have an x. Take that out. The next row, 2xy minus y squared. They both have a y. So take that out. In my first column, I have a 2 in common and an x in common. My second one, I've got a negative I have to pull out and a y. When I rewrite this, I have 2x minus y, x plus y, and 4. These types of problems we're going to see not as frequently, but they still are asked and expected of us. So that is all of the notes for 2.5 and 2.6. When we get into 2.7, it's more of the same skill, just some practice with some special cases. All right, thank you very much. I hope that you feel pretty good about it. It will take a lot of practice. We'll keep seeing it over and over again.